Hi, I'm Dimitris Haralambidis, and in this presentation we'll learn how to solve linear systems by substitution. One way of solving a system of two linear equations is by applying the method of substitution. This can be done following the steps below. In first step, we go to any of the equations we want and solve for any variable we want. As a tip, we could say here that we usually choose to solve for that variable that has 1 as a coefficient. Then, in step 2, we substitute the expression we got from step 1 in the equation we didn't choose. Now this equation will become an equation of one variable. In step 3, we need to solve the equation we created from step 2. In step 4, we substitute the value we got from step 3 in the expression from step 1. Now, we have the values of both variables, and finally, in fifth step, we write the solution as a point. Let's see an example to understand all these steps. Solve the system x plus 3y equals 6 and 2x plus 4y equals 10. At first, before we start, let's say that it always helps naming our equations. So, we'll name the equation x plus 3y equals 6 as number 1 and the equation 2x plus 4y equals 10 as number 2 respectively. So let's begin. In first step, as we said, we will go to any equation we want and solve for any variable we choose. Remember that, as we said, the easiest is to solve for the variable that has 1 as a coefficient. Hence, we will go to the first equation, to number 1, and solve for x. By doing that, we get that the equation x plus 3y equals 6 will now be x equals 6 minus 3y. Moving in step 2, we substitute this expression in place of x in the equation we didn't use. And that's the equation we named with number 2. So, we'll go in the second equation, and in place of x, we will now put all this expression. So, instead of 2x plus 4y equals 10, we will now write 2 times 6 minus 3y plus 4y equals 10. Notice that the second equation, the equation number 2, is now an equation of one variable. The only variable we have here is y. In third step, we need to solve this equation for y. So, 2 times 6 minus 3y plus 4y equals 10. Thus, 12 minus 6y, we applied the distributive property, plus 4y equals 10. Thus, negative 2y, we added similar terms, equals 10 minus 12. Thus, negative 2y equals negative 2. Thus, y equals 1. In step 4, we must substitute this value of y in the expression we got from step 1 to find the corresponding value of x. Remember that the expression we got from step 1 was the one that was writing x in terms of y. It was x equals 6 minus 3y. And now, in this expression, we will substitute 1 in place of y. So we'll get that x equals 6 minus 3 times 1. Thus, x equals 6 minus 3. Thus, x equals 3. And finally, in step 5, we will give the solution as a point. Therefore, we say that the solution of the initial system is point 3 with coordinates 3 and 1. For any questions about this presentation, you can leave comments down below, or you can contact me with one of the following ways. As always, thank you for your time.